Hi, this is GCSE Physics, and this is Pressure Lesson 3. Title, Atmospheric Pressure. Objectives, explain what atmospheric pressure is, and how when you increase in altitude, the atmospheric pressure drops. And then we're going to complete a pretty difficult exam-style question. Alright, let's move on. So, the atmosphere is a region of gas that surrounds the Earth, held in place by our gravitational field. Atmospheric pressure is produced by the gas particles undergoing collisions. The collisions specifically with the surface, at that altitude. So if you're on top of a mountain, you'll get gas particles, impacting on the top of the mountain. If you're at sea level, you'll get more particles impacting on the surface. And therefore, where there's more particles, you'll get higher pressure. Where there's less particles, you get less pressure. So the thing we need to know is, why does atmospheric pressure decrease with altitude? It's tied into what I've just said. You can see this graph on the right hand side, so you can see visually. So at sea level, the atmospheric pressure in kilopascals is around 100 kilopascals. As you go up in altitude, altitude is the height above the surface of the Earth, 10, 20, 30 kilometers, the pressure drops drastically. But why does that happen? So we can make some notes. So density, how compact the air particles are. As altitude increases, the atmosphere gets less dense. There is simply less air particles to collide with a given surface, therefore lower pressure at altitude, at higher altitude. And how much air there is. At an increasing altitude, there are less air particles above a surface, so the amount of weight that's pressing down, essentially trying to crush you from above would decrease. If you're at sea level, you've got more atmosphere falling on top of you. The higher you go up, if you went to the top of Mount Everest, which is however many miles up it is, and then you've got less atmosphere that's pressing all that weight down on top of you. Remember, if you need to take any notes, just pause. Alright, let's look at some questions then. So here's a couple of questions. The second one's pretty difficult, but if you want to have a go at them, please pause, and then I'll take you through the answers. So the first one, explain why atmospheric pressure decreases with altitude. Something along the lines of, the air molecules colliding with a surface create pressure. At an increasing altitude, there's fewer molecules above a surface. Therefore, the number of collisions with a surface decreases, resulting in less pressure. So there's always less weight of air than below. By below, it's comparing it to the surface. At the surface, there's more weight of air. Higher up you go, less weight of air above you. Let's look at that calculation. That calculation's similar to an exam style question that came up 3 years ago. So I'm going to show you how to do that one next, but it is tricky. So using the graph, calculate the force acting on an aircraft window of surface area 858 centimeters cubed. I don't know why that says cubed, that should be squared. Hopefully you realise that. At an altitude of 12 kilometers. The pressure inside the cabin of an aircraft is artificially maintained at 72 kilopascals. So we know the pressure inside the aircraft. So what we can do, we can look at the altitude on the graph. So an altitude of, I'll do this as straight as I can. So that's that. So 12 kilometers gives 20 kilopascals. So essentially, I'll try and do a drawing. So that's inside. Obviously, this is outside. So inside 72 kilopascals, and outside is 20 kilopascals. So essentially what we're dealing with is the force because of the difference in pressure. So the change in pressure between them, the delta, is 72 minus 20. So that's 52, a difference of 52 kilopascals. Because if you think about it, the inside's trying to push out, the outside's pushing in, but with much less force because of the pressure. So the difference between them, so essentially we've got a resultant pressure in that direction of 52 kilopascals. So that's our pressure that we're dealing with. Then we just need the area. So the area is 850 centimeters squared. So if you remember from last time, I'll do this again in case you didn't see it. So if you've got a square, 1 metre by 1 metre, that gives us 1 square metre. And if we did the same in centimetres, we'd have 100 centimetres by 100 centimetres, which gives an area that's equal to 10,000 centimetres squared. So to convert between centimetres squared to metres squared, we need to divide by 10,000. So in our question, it's 850 centimetres squared. So I'm going to divide that by 10,000, and that will give us the area, and that is 0.085 square metres. So now we can complete the question. So I'm just going to write that in, 0.085 square metres. So now we can get the force. So the equation, remember, is pressure is force divided by area. So force, we need to get rid of the divide by area, so we're going to times by area on the left-hand side. So force is pressure times area, and the pressure difference, which is what we're interested in, is 52 kilopascals. And kilo, remember, means 1,000, so that's 52,000 multiplied by the area, which is just calculated to be 0.085. So the resultant force would be 4,420 newtons. If I was guessing, well, an educated guess, I'd say that's probably it's at least a level 8. It's probably a level 9 question. It's very difficult. There's a lot in it. If you got that right, exceptionally well done. If you didn't get it right, what I'd suggest is rewinding the video, getting a blank sheet of paper, having another go at it, and make sure that you can do it. Okay. Anyway, thanks for watching. That's the last video on pressure for GCSE, and I'll speak to you soon.